Hello everyone, I'm Zhang and a Lantern Community Ambassador. Welcome to our series of courses on building Agent Red based on YAM and OceanBase. Today is our 5th session, and also the final one in the series. In the previous sessions, we introduced how to use Codio to build AI agents. We covered the basic architecture of corrective RAG, and in the last session, we talked about hybrid search. Thank you all so much for your ongoing attention and support throughout the series, and for joining us for all 5 sessions. Before we start today's session, let me briefly introduce our course website again. You can download all the course Jupyter notebooks from the site, as well as the environment setup and project dependency files, making it convenient for you to practice after class. If you want to discuss technical topics, feel free to scan the QR code below to join our Fishu group for learning. Alright, now let's get started with today's lesson. Today is the 5th session of our course series, which is all about data in, data out. The core focus of this session is to explore whether there are more ways to make the entire process of building a RAG even simpler. We'll introduce 2 approaches to you. The first is using a zero configuration built-in embedding, which requires no external dependencies and is ready to use out of the box for quick setup. The other approach involves a bit more programming and is called AI functions. These can be called directly within SQL or through our integration with OceanBase to access AI capabilities. Of course, this method still requires connecting to some external model services. In short, the advantage shared by both of these solutions is that you don't even have to rely on large model application development frameworks like LangChain. You can run the entire RAG process using just a database. Of course, you can still use those frameworks if you want. But now it can become an option rather than a necessity. This makes the entire tech stack much simpler, and it also reduces the mental load for developers. Alright, this course is jointly produced by OceanBase and the community. You're welcome to follow me on social media to learn more details about the course. Alright, so the content we're going to cover today mainly consists of 3 parts. First is Easy RAG, or what we call Zero Configuration RAG. The embedding model built into CD doesn't require you to provide an API key to access any external vectorization models, especially online models. With just a few lines of code, you can complete the current built-in key indexing process. That's the first part. The second part is AI functions, which are the built-in AI functions in seekdb. We'll introduce 3 core functions: AI embed, AI re-rank, and AI complete. These allow you to directly call AI capabilities within SQL and the database itself. You can use the database's own AI capabilities to complete the RAG process. The third part is where we'll show you how to use this all-in-one approach to complete a full recommendation process. You can also seamlessly integrate with LangChain, and the whole process actually offers even more options for our developers. Alright, let's first look at the first part. Why did we choose to present this to you? The construction of a REC system with the data in, data out framework. So when it comes to building a traditional REC system, there are actually quite a few troublesome aspects. Generally, you'll need an external embedding model. One way is to download this model locally, but usually we still use some online models. So you might also need some extra API keys and base URL settings. Then you have to use the corresponding SDKs to write the embedding calls and so on. In the end, you might also need to handle traffic management and some exception handling situations. Actually, you'll spend quite a bit of time just on the basic setup. But in reality, there are also logical parts. These are the areas where everyone actually needs to spend more time, right? So there will be some extra overhead if we choose a database with built-in capabilities like this. Things actually become much simpler. You might just need to connect to the database. Then you just pass the documents to it and use its built-in capabilities to create the index. After that, you can directly perform semantic searches. So it's really that simple. The key point is that we've built the embedding capability right into the database, so you don't need to use any external interfaces or SDKs. It allows for a basic out-of-the-box experience. So now, with support for capabilities like this, we can use simpler and more lightweight code to build a fairly traditional RAG architecture. Alright, so next, let's take a look at how CDB actually offers 2 different options for quickly building a RAG with this kind of solution. Earlier, we talked about using the built-in embedding and vectorization capabilities to do this. This approach provides support directly. The advantage is that you don't need to configure anything extra. So for example, you don't need a key, and it comes with a built-in vector model for you, although the dimension of this model is a bit smaller. For everyone, it basically means you don't have to worry about anything. In a moment, we'll look at some code and you can just use it directly. Just use this database and you'll be able to upload your files, have them indexed directly, and then retrieve them right away. It's a straightforward process of indexing and searching. It automatically handles the vectorization process. So for us, it's like a black box, which makes it really suitable for rapid prototyping, learning, and testing. Basically, all of these can be covered here. The second method is a bit more complex, but also gives you more control and it's more powerful, and that's AI functions. This method provides a series of core functions. For example, here you'll see AI embed, which is used to generate vectors, AI rank for re-ranking, and AI complete for generating responses. With this approach, you need to configure these endpoints all at once. And of course, these endpoints will actually connect to some of our remote model services, so they still require support from those model services. However, all the operations are handled at the application layer of the database, so you don't need to use any additional frameworks. Frameworks like LangChain, for example, are no longer necessary. So overall, you can really focus on mastering a single database. And with this database, you can develop entire systems or even build related agent systems if you want. It's all possible. Some capabilities can be extended in this way, so everyone can spend more time focusing on business development, which is actually more worthwhile. Alright, so these two solutions are what we're currently offering, and you can choose based on your actual needs, or even use them in combination. Of course, you might be wondering whether other frameworks or databases can do similar things as well. Here, we've included a table from an open source code repository. You can take a closer look at it offline if you'd like. In this table, there are actually a lot of comparison dimensions listed, and you can go through them one by one in the first column. You can also see things pretty clearly in this table. CDB is quite comprehensive when it comes to overall capability support, while other databases each have their own strengths and unique features. However, in the scenario we're discussing today, where you want to provide a more all-in-one rec service, CDB is actually a pretty good choice. Of course, you can still look into other databases and see how they might work together with our current large model to make the reg system even better. This table is just meant to serve as a basic reference for everyone. Alright, moving on, in the second part, we'll introduce what data in, data out means, and specifically how we can implement this concept. Alright, first of all, our reg lifecycle system actually has two very clear parts. The first part is building the index, which is what we call data in. Generally, this involves 4 steps: loading the documents, splitting the documents, generating vectors, and then storing them in the database. As for data out, that's basically the query phase, which also consists of about 4 steps: receiving the user's question, retrieving relevant documents, then indexing and re-ranking, and finally generating the answer. In both of these processes, some core capabilities are actually built in. This includes the built-in embedding we saw earlier, as well as AI functions that provide ranking and answer generation capabilities. All of these are integrated within CSTV. The entire process can actually be completed through a database service. So first, in the data in workflow, the first 2 steps are basically handled using various methods. For example, what I showed you earlier was all done using a document loader to load the documents. For tasks like chunking and processing, I still recommend using some traditional methods to get them done. Then when it comes to the vector generation step, we now provide a built-in, modern, lightweight model that you can use directly. This way, you don't need to connect to any external services. Of course, if you still want to use more powerful online models, you can absolutely continue to do so. We've provided the AI embed function within AI functions to connect everything together. This way, the vectorization capability can be handled right at the database layer, and the final data entry into the database, well, that's already a core capability in itself. In the previous session, we also introduced our strong support for hybrid search capabilities. As for how to perform hybrid search and data entry, we actually covered that in detail last time, so you can refer back to that. So these 2 aspects, vectorization and storage, are essentially handled at the database layer itself. These are very core capabilities. Okay, so in the data out process, the first 2 steps are to receive the user's question and then perform basic vector search, which is a fairly standard technique with many available methods. Here, what we want to highlight more is the use of AI and function-based error ranking. You can bind an external RAG model and then directly re-rank the search results within the database. After that, the data is fed back and provided for subsequent question answering. So both ranking and question answering can happen within the database service itself without needing to chain things together using LangChain. You can directly use, even as you'll see later, just some SQL code, SQL type code, to accomplish this kind of operation. So this kind of experience is actually really different from the way we used to do things before. Now, you can see that with AI capabilities integrated into the database service, its boundaries have been greatly expanded. This is something everyone needs to notice. All right, next, let's show everyone the first solution, which is creating a zero configuration rack. The goal of zero configuration RAG here is very clear. We don't need everyone to configure external vectorization models anymore. So how exactly is this achieved? Actually, it's because a model like this is already built in, specifically the OR Mini LM L6 VR model. It's a small vectorization model with 384 dimensions, which is really helpful for us when building prototypes, especially for rapid prototyping. Because during the building process, you don't have to worry about things like if you've never worked with RAG before, you might first need to figure out what a vector model is, and then find a way to connect to an online vector model. And then you'd also have to know its dimensions and deal with a bunch of other stuff. But now you don't have to worry about any of that. Basically, you just pass your data directly to CPB, and you can even forget about vectorization altogether. You can just get started right away, and the whole process becomes much faster. So if we go back to OceanBase and look at the code, you'll notice that before, if you wanted to use a vector store to perform operations, you definitely had to provide an embedding model. But now, you don't have to. You can just skip that step. If you use CDB, you can set it to null, and in that case, we can directly use the built-in drop-down model to generate vectors. So once you've set it up, the way you perform similarity searches afterward is exactly the same as before. You can skip the important step of configuration. There is no need to worry about any of that. For those who are just getting started with the React ecosystem, this is a really good option. You can get the whole thing up and running first. In the future, you can still choose to use the traditional way to connect to online or local vector databases. But in the beginning, you can greatly reduce your operational burden. And finally, the overall experience is that you just need to import your files directly. Just focus on bringing your files in. Then after that, you can just unlock it directly. So this is what we call the essence of data in, data out. What we focus on more is the business data, putting things in and having the ability to retrieve them, rather than worrying about having to configure A, B, C, D, E, F, G, and a bunch of other things just to get something out. Sometimes, even after all that configuration, you still run into all sorts of problems and end up retrieving nothing at all. So this is actually a big change. Here we've introduced a step called auto embed, all right? Of course, if you want this to still work with the LangChain ecosystem, that's totally fine. What we've actually changed is just setting the embedding to none, so you don't need to configure the vectorization model anymore. The rest of the process remains the same. You can still turn the vector store into a retriever and then use the retriever for this purpose. Traditional chain construction or agent development can absolutely continue as before. There's no change at all here. All right, so as we can see, by using this zero configuration approach, we actually get some real benefits. For example, we don't need any extra external APIs to set up the vectorization model. With the same database, we now centralize all the storage and vectorization processes in one place, so there's absolutely no need for additional services. The connections also don't disrupt the traditional ways of linking and combining things. If we compare the traditional coding and Rex development methods with the current approach, the amount of code we need to write is actually significantly reduced. So everyone can focus more on developing your business logic. Especially at the prototyping stage, this approach really lowers the entry barrier quite a bit. Alright, next let's look at the second part. This section will provide even more powerful built-in AI features, which we call AI functions. The zero configuration solution we saw earlier, like the embedding approach, is relatively simple. But because it's relatively simple, a lot of the time we can't really achieve great development results using just these small models. So more often than not, we still need to use some better online models, like ranking models or others. However, here we actually encounter another situation. One option is the traditional approach, where we use toolkits like LangChain to connect everything together. But now actually we have another choice. We have databases with built-in AI capabilities. That means we can use the AI features built into the database, especially the way they're packaged in the SDK, to do this. We can use it to complete the entire ranking process, including embedding, ranking, and answering questions. It's all possible now. So this is actually a really imaginative and promising change. Now, with your program, where you might have originally needed to integrate with, say, 6 different databases and so on, you may now only need to interact with CDB. By using a few built-in AI functions, you can complete the basic RAG workflow. So in this way, your architecture will definitely become simpler, and your development experience will be quite different. All right, let's take a closer look at the three core AI functions currently provided. What are they? Their main function is to convert text into vectors. It's used for vectorizing our data after it comes in. This is the most basic step for us to perform retrieval augmented generation, RAG. Here, we can also use external vector services. You can bind it to the modern model of your choice and then let it operate here with modern support. The second part is called AI re-rank. This is used to re-rank the search results, which can help us improve the relevance of the search results. Put the most relevant articles at the top, mainly to improve the quality of retrieval, because for large models, whether your content is at the front or the back actually makes a difference. The more relevant the content, the better it is to place it closer to the front. Ah, okay. So for us, it's the same. We can also connect to external models and then handle this task directly within the database. There's no need for any additional external SDKs for support. And the last one is AI Complete, which can call external conversational models to provide answers. So up to this point, you'll notice that all these tasks are actually connected through LangChain. Now, a database can say, I'll handle all of this for you. Your questions and answers are all managed within the database itself, and it can help Touch get things done directly. You can even do this by writing SQL. So the entire process is handled completely through a database service. Text comes in, gets embedded to generate vectors, then after retrieving the results, AI rank is used to re-rank them. And finally, AI complete generates the answer. Pretty interesting, right? This basically takes away the jobs that used to be for the younger folks. If everyone gets used to this approach, especially those who are already familiar with databases, you don't even need to learn LangChain anymore. Now you have an extra way to develop a really solid RAG ecosystem just like everyone else. You can directly develop a callable class like this. Alright, so let's take a look at how we actually complete this endpoint binding. First, we need to define the AI model. This model definition refers to what we need to do in the database. Let it know which AI models we currently have, who their providers are, and which specific model we're using. Then, we need to create a binding between this model and the platform that provides it. Similarly, you need to set the base URL, the API key, and all those configurations. Once that's set up, the rest is easy. You just use the three functions we mentioned earlier, AI embed, rank, and complete. You can then separately carry out our processes for vectorization, ranking, and Q&A handling. Alright, now let's take a closer look at each of our functions one by one. First up is AI embed. This one is pretty straightforward. We've actually mentioned it several times before. Its core purpose is to use this function to achieve vectorization. The operation is actually completed within the database, not externally using LangChain. Then, the vector content is stored directly into the database. So here, we quickly generate the vector in just one step, so to speak. And then, at the same time, it's entered directly into this vector storage. So the operation becomes very straightforward. If we look at how it's used in OceanBase, for example, the usage is pretty much like this. This is how you would use it. You can use our OceanBase client to connect to OceanBase and perform operations and calls. And if you want to understand what's happening behind the scenes, you can see it on the left side. What's actually happening in the background is that it's still a way of operating using SQL functions to generate and perform this kind of vectorized processing. So how should I put it? If you're used to developing in a connected sequential way, you just need to focus on the left side. But if you're more accustomed to working with databases, you can use the approach shown on the right side. You can choose whatever suits your needs. The underlying principle is still based on SQL, so you can look into it if you're interested. The advantage is that it allows you to break free and leverage the database's own AI capabilities to handle things. This is especially true for managing related data, particularly after it's been vectorized. It also enables further upward scalability and cluster expansion of the database. Alright, the second point is AI re-rank. The main purpose of re-ranking is to arrange the initial search results in a better order, so that higher quality content can be presented earlier for the large model to read, and then carry out subsequent reasoning. Here, we can also use our AI function called AI rank to perform the related operations. Alright, so here we can also implement a curation process, which can also be done at this stage. After you finish ranking, you can further narrow down your documents, the range of documents provided to the large model. Actually, this is something we can achieve through the rank step. As for how to use the AI rank function, it's also quite simple. In LangChain OceanBase, we can use this method. On the left side, we can call the AI rank function in this way. On the back end, on the SQL side, you can also see there's another way to call it. It still uses this kind of SQL syntax for processing. Just like I mentioned earlier, if you're familiar with LangChain, just look at the first part. If you're more used to database SQL operations, then focus on the right side. You can use this as a reference. The biggest advantage of this approach, as mentioned earlier, is that you have the freedom to choose whether you want to rely on external dependencies or just use the SQL you're most familiar with to handle everything yourself. Alright, so the last part is this. Now that we have the retrieved content, we need to generate the answer or response. So here, the first step is also to get the results, then rank them, and finally, the last step is generation. So now we're at the generation stage. The generation stage actually seems pretty simple, but if we look at it from a coding perspective, the biggest difference is that in the past, this process was probably done through a fully connected layer. But now, after you get the results, this process is also handled using It's now accomplished using the database's built-in AI functions, and on the right side, you can also see its corresponding SQL implementation. Honestly, even though we started out as database developers ourselves, I have to say, seeing this database, an AI native database, being able to provide both vectorization capabilities and some AI functions at the same time is actually pretty surprising. We really didn't expect that. While we were talking about how LangChain and OceanBase work together to build RAG, we suddenly realized that a database service has already made a small revolution in this area. It can actually get rid of these connections, external dependencies, and then build a RAG system. So honestly, with the development of our overall infrastructure, the possibilities for the future are really becoming endless. So going forward, you'll actually notice, especially if you're familiar with SQL, you can actually use SQL to connect the entire process together because all the data is in the database. By using SQL, you can link everything up nicely without having to constantly transfer data or information back and forth between external and internal systems. You'll find that this makes things a lot simpler. Many times, there's actually a lot of room for imagination here, but we won't go into detail today. So in the end, let me show you a complete rack process so everyone can get a better feel for it. Let's say if we replace the traditional bat-style approach with something new. Using the AI functions provided by OceanBase for user groups, how should we go about building a reaction state? Alright, so you can basically see it in this big slide below. Overall, compared to the original approach, the difference isn't actually that big. The first step is to create a vector index, which you can do in various ways, including using the built-in embedding method. You can use AI embedding to get the data. After that, you can use the AI function error rank to perform re-ranking, and finally, you can use AI complete to answer a question. Here, the main point is that although this sample code is simple, the biggest thing is that you can either use the human rights approach to connect and combine things, or you can completely set aside the connection with LangChain. You can also use the CDB method to connect the entire process together. Of course, in actual production, besides using the rack system to link these process chains, it can also provide many richer capabilities, especially in terms of agents. So, in fact, we still recommend that everyone use chaining to connect everything as a whole, but when you combine different methods, you'll have more options. If you think that higher efficiency should be achieved directly within the database, and then finally, get a result and then pass it to the Lantern agent for further reasoning. In fact, you can consider using the approach you see here, letting more of the data processing happen within the database. Instead of pulling all the data out, processing everything, and then interacting with the database again or something like that, you now have more choices here. Alright, so finally, let's do a quick summary for everyone. Today, we actually covered 3 core topics. First, we looked at our embedding building capabilities. With this zero configuration approach, you can quickly use our vector storage to build a foundation for RAG. This means we don't need to do any extra configuration for vector models. You can jump straight into building data indexes, and then move on to the data retrieval process. This is really helpful for rapid prototyping. The second point is that CDB provides us with the capability of AI functions, which are more geared toward advanced use cases. At the database level, we combine external models such as conversational models, vectorization models, and ranking models. The entire processing workflow is contained within the database to complete tasks like retrieval, re-ranking, and generating answers to questions, forming a closed loop. This way, you can break free from dependencies on some external large models or development frameworks, or at least have more options, because the core operations are actually handled by the database itself. So in this situation, chaining integration becomes an optional choice. Of course, if you're working in an Adrian scenario, we still recommend combining chaining with other tools. As we saw earlier, we can use the Chaining OceanBase library to effectively combine the capabilities of the database with those of chaining. But now, since the database is self-contained and can complete this kind of closed-loop capability on its own, it provides everyone with a really solid foundation. You now have more options for combining different technical frameworks, and that's actually a pretty big change. All right, so the things mentioned earlier are also pretty much related to the core content of this session. To sum it up one last time, first, there's zero configuration startup. Second, AI functions. Third, the flexibility to choose from the ecosystem. And finally, our all-in-one database capability, which can package everything together and make building the RAG process very straightforward and simple. All right, so finally, just like before, we've prepared a detailed notebook for everyone that covers all the content above. It includes embedding, how to build embeddings, how to use them, and how to configure and use AI functions. It also includes sample code for the rack process and other types. The entire demonstration uses LangChain OceanBase, so through this notebook, you can learn all the details of what we've shared in this session. We also encourage everyone to try it out yourself, so you can really get a feel for it. The so-called all-in-one AI function might sound a bit mysterious at first, but by putting all the retch process operations into a one-click solution, you'll get a much more direct experience and understanding of how it all works. All right, that brings us to the end of today's session. This episode is also the last one in our series. I want to sincerely thank everyone for your company and support all along the way. From our very first episode, to the second one on basic architecture, then the third on correctness, and the fourth on hybrid search. And now, with today's final episode on data in, data out, I hope that the content from these 5 sessions has inspired and helped everyone in learning how to build an agentic RAG. You're also welcome to scan these QR codes to learn more about the core features of LangChain, OceanBase, and related topics. Although this course is coming to an end, learning and communication never stop. We warmly invite everyone to visit the bottom of our course webpage and scan the QR code for our Facebook group. You're very welcome to join the group for ongoing discussions, so we can explore and learn together. Use LangChain and OceanBase to develop content related to our R agent. All right, thank you again for your attention. We look forward to bringing you more courses in the future. Thank you, everyone.